Good day everyone, my name is Samantha A. Bolan from DS102 and I am here to present graphs and its applications. Our overview is to introduce the theory of graphs, types of graphs and its application of graph theory. Graph theory is a branch of mathematics concerned with networks of points connected by lines. The subject of graph theory had its beginning in recreational math problems, but it has grown into a significant area of mathematical research with application in chemistry, operation research, social science, and computer science. The history of graph theory may be specifically traced to 1735 when the Swiss mathematician Leonhard Euler solved the Königsberg Bridge problem. The Königsberg Bridge problem was an old puzzle concerning the possibility of finding a path over every one of 7 bridges that span a forked river flowing past an island, but without crossing any bridge twice. Euler argued that no such path exists. His proof involved only references to the physical arrangement of the bridges, but essentially he proved the first theorem in graph theory. So here is bridges of Königsberg illustration. As used in graph theory, the term graph does not refer to data charge, such as line graphs or bar graphs. Instead, it refers to a set of vertices and edges that connect the vertices. When any two vertices are joined by more than one edge, the graph is called multigraph. A graph without loops and with at most one edge between any two vertices is called a simple graph, unless stated otherwise. The graph is assumed to refer to a simple graph when each vertex is connected by an edge to every other vertex. The graph is called a complete graph. When appropriate, a direction may be assigned to each edge to produce what is known as a directed graph or diagram. Now, we're gonna discuss the types of graphs. First one is null graph. A null graph is a graph in which there are no edges between its vertices. A null graph is also called an empty graph. As you can see, there is no edges connected between them, so that is a null graph. Trivial graph. A trivial graph is a graph that has only one vertex. In the above graph, there is only one vertex, V, without any edges, therefore it is a trivial graph. Simple graph. A simple is an undirected graph with no parallel edges and no loops. In a simple graph that has n vertices, the degree of every vertex is at most n minus 1. In the example above, the first graph is not a simple graph because it has two edges between the vertices and A and B, and it also has a loop. The second graph is a simple graph because it does not contain any loop and parallel edges. Undirected graph. An undirected graph is a graph whose edges are not directed. In the above graph, since there are no direct edges, therefore it is an undirected edges. Undirected edges has no arrow or lines that is pointing to the next node. Directed graph. A directed graph is a graph in which the edges are directed by arrows. The directed graph is also known as digraphs. As you can see in the picture, that is what directed graph looks like. It has some point that is pointing on what node. Complete graph. A graph in which every pair of vertices is joined by exactly one edge is called a complete graph. It contains all possible edges. Since each vertex in the graph is connected with all the remaining vertices through exactly one edge, therefore both graphs are complete graphs. Connected graph. A connected graph is a graph in which we can visit from any one vertex to any other vertex. In a connected graph, at least one edge or path exists between every pair of vertices. In the example, we can traverse from any one vertex to any other vertex. It means there exists at least one path between every pair of vertices, therefore, it is a connected graph. Next is disconnected graph. A disconnected graph is a graph in which any path does not exist between every pair of vertices. The graph consists of two independent components which are disconnected. Since it is not possible to visit from the vertices of one component to the vertices of other components, therefore it is a connected graph. Regular graph. A regular graph is a graph in which the degree of all the vertices is the same. If the degree of all the vertices is k, then it is called a k-regular graph. In the above example, all the vertices have degree 2, therefore they are called two regular graphs. Cyclic graph, a graph with n vertices, where n greater than or equal 3 and n edges forming a cycle of and with all its edges are known as a cycle graph. A graph containing at least one cycle in it is known as a cyclic graph. In the cycle graph, the degree of each vertex is 2. The cycle of graph which has n vertices is denoted by Cn. In the above example, all the vertices have degree 2, therefore they are a cyclic graph. This is another example of cyclic graph. Since the above graph contains two cyclics in it, therefore it is a cyclic graph. Bipartite graph. A bipartite graph is a graph in which the vertex set can be partitioned into two sets such that edges only go between sets, not within them. A graph G PE is called a bipartite graph if its vertex set VG can be decomposed into two non-empty disjoint subsets V1G and V2G in such a way that each edge EG has its one last joint in V1G and other last points in V2G. The partition V1 union V2 is known as a bipartition of G. Complete bipartite graph. A complete bipartite graph is a bipartite graph in which each vertex in the first set is joined to each vertex in the second set by exactly one node. A complete bipartite graph is a bipartite graph that is complete bipartite graph equals bipartite graph plus complete bipartite graph. Star graph. A star graph is a complete bipartite graph in which n-1 vertices have degree 1 and a single vertex have a degree n-1. This exactly looks like a star where n-1 vertices are connected to a single central vertex. A star with n vertices is denoted by Sn. Out of n vertices, all the n-1 vertices are connected to a single vertex, hence it is a star graph. Weighted graph. A weighted graph is a graph whose edges have been labeled with some number weights. The length of a path in a weighted graph is the sum of the weighted of all the edges in the same path. Multigraph. A graph in which there are multiple edges between any pair of vertices or there are edges from a vertex to itself. Loop is called a multigraph. In the picture above, vertex set B and C are connected with two edges. Similarly, vertex sets E and F are connected with three edges. Therefore, it is a multigraph. Planar graph. A planar graph is a graph that we can draw in a plane in such a way that no two edges of it cross each other except at the vertex to which they are incident. The above graph may not seem to be planar because it has crossing each other, but we can redraw the above graph. That is for the first picture. The second picture is three graphs do not consist of two edges crossing each other, and therefore all of the above graphs are planar. Non-planar graph. A graph that is not planar graph is called a non-planar graph. In other words, a graph that cannot be drawn without at least one pair of its crossing edges is known as a non-planar graph. The applications of graph theory is, or we can apply graph theory in computer science, electrical engineering, linguistics, physics and chemistry, computer network, social science, biology, and mathematics. Graph theory is used in a vast area of science and technologies. So that is all. Thank you so much for listening.